So in this lesson, I want to have a look at the different types of solutions we could have. Um, we've been looking at equations where we've been finding points of intersection, or POI. So most of the work that we've been doing looks like this middle picture, and we call those intersecting lines. But we can also have situations where we have two parallel lines, and we can also have a situation where we have one line overlapping the other. So let's have a look at how we can determine which type of the three solutions we're going to have, even before we do any work. So on your page, types of solutions, you may want to copy down some of these definitions and characteristics so you know what to look for. So parallel lines are equations that have the same slope and a different y-intercept. So let's have a look. So here we have two equations. And notice that they have the same slope, a slope of 3 and a slope of 3. They have different y-intercepts. This one has a -1 y-intercept, this one has a +4. That means that we have two parallel lines because they both have the same slope. And notice that these two have different y-intercepts. Now these lines are not exactly the lines for these equations, but just a general example. So these show that we would have the same slope and a different y-intercept. This line cuts the y-axis here, and this line cuts the y-axis here. So we can tell before we even do any work, we can look at this equation and we can determine that there isn't going to be a point of intersection. So we can say that there's no solution to this set of equations, and so we needn't bother doing any work. We needn't bother doing substitution or elimination because it will just be a waste of time. But if we did do substitution or elimination, we would end up with a solution like this. We would get stuck at a certain point. When we try to, if we're doing elimination and we try to subtract or add the two equations, we would get something like a 0x equals 5. Now that's not solvable. We would get stuck at that point because when we do swing underneath, we can't do 5 divided by 0. If you try that on your calculator, you will get an error message. Okay, so you need to be able to recognize when you see these two equations, I may ask you what type of solution is this, and for this one our answer would be no solution, because the reason is that they have the same slope and a different y-intercept. So the same slope and a different y-intercept. Okay, let's look at intersecting lines and an example of types of equations we might see. So notice that these equations would have different slopes. That's all we need to check. If they have different slopes, that means that we would be able to find a point of intersection here. So notice that this line has a slope going this way, and this line has a slope going that way. This one would be a positive slope, and this one would be a negative slope. It doesn't matter what the slopes are, as long as they are different. And the y-intercepts don't matter either. So this is a type of question where we may get an answer of something like this, and we've been doing the process of substitution or elimination to find such a solution. So we would say that this set of equations has exactly one solution, and we would be able to find it, and we've been writing our solution as an x comma y coordinate point. So x would be a number and y would be another number. Let's look at what the same lines would look like in terms of their equations. So these would have the same slope and the same y-intercept. So notice these two equations. Now sometimes they try to trick you because this looks initially like two different equations, but really it's not. Now I said we would have the same slope and the same y-intercept. This says 3 for slope, and this looks like it says 6. This says 4, and this says 8 for y-intercept. But what's happened here is the second equation is just a double of the first. So if we take the first equation, we multiply it by 2, we get exactly this equation. So that means that they do have exactly the same slope and the same y-intercept. If I was to divide this equation by 2, because I have to have a y equals equation in order to analyze it. So if I was to divide this by 2, this by 2, and this by 2, I would end up with exactly the first equation. And notice how the picture looks. It's got both of the lines are on top of each other. That means they both have the same slope and they both have exactly the same y-intercept. That's how you know it's different from the first picture, because these have the same slope but they have different y-intercepts, okay? So this solution, if we were to try substitution or elimination, our solution would look like this. We would get stuck at a point where we would have 0x equals 0. So notice how it's different from this solution. This one would say 0x equals a number, and it doesn't have to be 5, it could be any number. But this one will always say 0x equals 0, and that's how you know that you have two of the same lines on top of each other. And this solution is called an infinite number of solutions. And the reason is because when we're trying to find the solutions to a set of equations, we want to know where do they intersect. This one never intersects, so we call it no solution. This one has one point of intersection, so we call it one solution, one exact solution. Now, if you ask yourself how many points do these two lines have in common, they have many, 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 many points. Every single point on the line is in common with the other line because they're overlapping. And this would continue on. This line continues on forever, so we have many, many solutions. And so we call that an infinite number of solutions. So now you can determine, if you were given a set of equations, you would be able to analyze and determine which type of solution you would have. And that's a very good thinking question.